Hello everyone, this is Amika Mahajan. Welcome to my channel. This video is focused on volume charge distribution. I will find force, electric field and even potential due to volume charge distribution. We consider a volume V having charge Q with charge density rho such that rho is Q by V. This rho is a function of R. I consider small segments, each of volume dV. Here I am considering this cube having charge dq. dV is macroscopic, but it contains microscopic charge constituents, and dq is charge in element dV. Any point on this volume charge distribution has position vector r from point O. And we consider a point P where charge q naught is present, whose position vector is r naught from this point O. Now, what we do, we divide this distribution in small volume elements such that this rho is equal to dq by dv. So what will be charge in this element? It will be rho dv. We will find force due to this element on q naught charge. This force will be given by Coulomb law. We will multiply q naught by dq because I am finding force due to this element. So it will be df. Q naught into dq divided by 4 pi epsilon naught, distance of this dq from q naught. It will be this displacement vector. That is r naught minus r vector. So what we do? We take square of this and magnitude. Now, when we find force due to small element on charge q naught, which is placed at point P, to find force due to whole volume charge distribution, we integrate. When we integrate, what we get, q naught dq by 4 pi epsilon naught r naught minus r vector ka magnitude ka square, and this dq is replaced by rho dv. So this is another expression for force, and force can be expressed in vector form by multiplying this magnitude with unit vector along the line joining dq and q naught. Now, this is force. We can also find electric field due to this segment dq, then whole volume charge distribution at point q naught. When we find electric field due to whole charge distribution at point P, what we have to do? We have to divide this force by test charge placed at point P, and what we are considering that this test charge is vanishingly small. When I divide this force by q naught, but I get rho dv by 4 pi epsilon naught r naught minus r vector ka magnitude ka square integration. This is field due to whole volume charge distribution at point P. Now, this can also be expressed in vector form. What I have to do? I have to multiply this magnitude with unit vector along this line joining dq and q naught. That unit vector will be r naught minus r vector divided by r naught minus r ka magnitude. So when I multiply this term with this factor, what I get? Cube in denominator with magnitude of r naught minus r. Now, to find potential at point P, so I consider it to be V dash because already V I have taken for volume of this distribution. Now, we know that potential is given by charge on this element divided by 4 pi epsilon naught r naught minus r ka magnitude of this vector, which is drawn by joining dq and q naught. This, when I don't put integration, it will be dv, small potential due to the small element actually. When I have to consider whole volume charge distribution, then I will integrate, and it will be v dash equal to integration of rho dv 4 pi epsilon naught r naught minus r in denominator, but its magnitude. Well, this potential is a scalar quantity, so don't express it in vector form in any case. Thanks for watching this video. Like, share, subscribe my channel.